Hello everyone, my name is Milad and in this video I'm going to show you how you can create a custom ChatGPT implementation that can answer your tax inquiries. For the sake of this tutorial, I'm going to assume that you have some familiarity with Python. That's the only requirement. By the end of this video, you're going to have a simple chatbot such as the one you see on the screen, where you can ask your tax questions and get a reply back. So let's give it a go. Let's ask, what does it mean to have a tax bill? Here's the answer. So you might wonder, why do we need to create a new chatbot where we can just use ChatGPT? The answer is, if you need your chatbot to give you more accurate information, you need to provide it with additional context. In my case, where I live in Melbourne, Australia, I'm going to provide our chatbot with additional information from the ATO website. ATO stands for the Australian Taxation Office. You can use a different website depending on what country you live in. Okay, so before jumping into code, let's go through the steps together. The first step is creating a ChatGPT API token. This token is going to be used by our chatbot to call ChatGPT endpoints. The second step is creating a scraper for ATO. We're going to use the Scrapy Python library to scrape all the regulations and laws summarized on the ATO website. The third step is creating an index of all the documents and then storing that into the hard drive. We're going to use llama-index for that. And the final step is putting everything together into a chatbot. For that, we're going to use Streamlit. Okay, let's do the first step. Let's go to platform.openai.com. Feel free to sign up if you haven't already, but let's log in after. I'm going to go to Dashboard, and then from the left panel, I'm going to choose API keys. Go ahead and create a new API key. Give it a name. I'm going to call it Tax Agent API and hit create. Don't forget to copy this API key. We're going to need it later. Okay, so now that we have our API key, let's get into coding. I'm going to use PyCharm for this project, but you can use whatever IDE you prefer. Let's go ahead and open PyCharm. Okay, I'm going to create a new project and call it Tax Agent. Alright, so the first step is installing Scrapy, the library we're going to use to scrape the ATO website. So I'm going to do pip install Scrapy. Okay, that's done. By the way, we don't need the main.py file, so we can remove that. Okay. So the next step is creating a Scrapy project. To do that, I can just type in Scrapy start project, and then I'm going to give it a name. I'm going to call it Tax Scrapy. Okay, so now you can see that there is a new folder here called Tax Scrapy, and then it created a bunch of Python files for us. It is some boilerplate code that we don't have to create every time we want to create a new scraper. So that's good. Now we have to cd into Tax Scrapy, and then we have to create a new spider. A spider is basically the agent that's responsible for crawling whatever web page we want to crawl. So I'm going to type in scrapy gen spider, and then I'm just going to give it a name, and then I have to give it the address for the website we're going to crawl. It's ato.gov.au. Okay, all good. Okay, now you can see that within the tags scrapy folder, there is a spiders folder, and within that, there is the new spider that we just created, and it's called tags. So if you have a look at the code, it has a bunch of generated code. This is our start URL, and this is a list of all the URLs that we're going to allow to be scraped. Okay, so to give this a go, we can just type in scrapy crawl. This is our spider name, tags, and then we're going to output the results into output.json. Okay, all done. If you open up output.json, you can see that it's an empty file now, and that is because our pause function hasn't been implemented yet. So we're basically crawling that page, but we're not doing anything with the result of that crawl. So we have to fix it, and we can fix that by implementing the pause function. So let's do that. Okay, so let's get rid of the output.json file and then start implementing the pause function. So I'm going to do page text equals, this is not a bad suggestion by GitHub Copilot, so I'm just going to go with that, but I'm just going to add body to the beginning because we're only interested in the text of the body. So if you look at the documentation for get all, you can see that it's actually returning a list of strings. So we want all those strings attached into one big chunk of text. So to do that, we can just type in this and join all the elements together with a space in between. So I'm also going to add strip at the end because we're not interested in the beginning and ending space of every element. Okay, and what I'm gonna output is a JSON with this structure essentially. Okay, I do yield. Okay, so this is a simple JSON. It contains two elements, the URL of the page that we're going to crawl and then the actual text of that page. This is what's going to go into the output.json file. So let's give it a go. All right. So now if you check the output.json file, you can see the content of the page. This is the URL and this is all the text within that page. Okay, so this is good for crawling the home page, but what about all the other links that are mentioned inside the home page? We want to get those as well, right? So what we're going to do after getting the home page is extracting all the links within the page, and then we have to scrape those pages as well. Okay. Okay. This is again actually a good suggestion. So if the link starts with HTTP, then we can crawl that page as well. If it doesn't, it means that it's a relative link. So we're going to attach that relative link to the link of the original home page and then scrape it using the parse method. Okay, so let's give this a go. Okay, so as you can see, this never ends. And the reason is we're crawling a page, we're crawling the links within that page, and we continue doing so. And in those second pages, there are also other links. So this will go on forever. So we have to find a way to stop it at some point. Okay, so let's discuss that in more detail. We're starting with ato.gov.au, and then we're scraping the links within ato.gov.au next. That's going to be considered depth 1. And the next set of links are going to be depth 2. So if we can find a way to parameterize the depth, then we can find a way to finish the job of scraping at some point. So let's code that. Okay, so coming back to our code, let's do two different things. Get rid of the output file first. Okay, so I'm just going to add a constructor to our class. All right, and then I'm going to add a max depth parameter. I'm going to initialize it with 1. Okay. So I'm going to call the super constructor first, and then I'm going to assign max depth to the class. Okay. It's good enough. And then I'm going to adjust the parse logic as well. The first thing I'm going to do is actually I'm going to get the current depth. So I'm going to store the depth of the scraper inside the metadata, and then I'm going to call it the depth metadata item, and then I'm going to initialize it with 0. And now I'm just going to add an if condition here, checking for the depth. So if the current depth is smaller than the max depth, then we can continue. All right, I'm going to extract the links first. So I'm going to bring this line of code here. And instead of yielding directly, I'm going to assign the link into next page. I'm going to do next page equals link, and then next page equals response the URL join link. All right. The next thing we want to check is the next page link is also within the allowed domains or not. So we have to add another if condition here. If any domain in next page, this is actually accurate. So if we stay within the same allowed domain, then we can yield the result. The only change we have to make here is, let's write this line again. So it should be scrapey.request. Yep, this is accurate. So scrapey.request next page using the parse function, and then we add 1 to the depth. Okay, this is good enough. Okay, so before testing the spider, let me make a few other changes as well. The first thing is, I want to make sure that if I visited a page, I don't want to visit it again. So I'm going to do self.visited URLs to an empty set in the constructor, and then I'm going to add whatever link I'm crawling into the visited URL. So I'm going to add response URL to the set of visited URLs. Okay. And then I'm going to add one more condition into my final if. So I'm going to do parameter. So I'm going to do and next page not in visited URLs. For the sake of tracing, I'm going to add depth to the output as well. So let's give this a go. I'm going to do scrapey crawl tags, and then I'm adding max depth to the end as well this time. Okay. Now you can see that the depth is also added into the output. And for some of the entries here, the depth is 1. So you can go as deep as you want, just be mindful of the time that it will take to scrape everything. Okay, so as you might have noticed, every crawled page is put into the same file, and you know, as you crawl more and more pages, this file gets bigger and bigger, and sometimes it is really difficult to open the file. So what if we could just have one file per page instead? To do that, we have to modify the scrapey pipeline. So if you navigate to the text scrapey folder, you can see a pipelines.py file. What we have to do is modifying this process item function. So let's do that. Okay, so before returning an item, let's add more logic. I want everything to be stored inside a folder called output files. So if it's not created, then I'm just going to create it myself. So it's the path that exists. Yep, this makes sense. I just have to import OS. All right. And then I have to name the file. So I'm just going to name it output and then underscore and the file index. Okay, so we have to define what the file index is. To do that, we have a constructor-like function that we can override. I'm gonna do def open spider, and then I'm gonna start with 1. All right, so let's open the file and prepare it for writing. Yeah, and then we can just dump the item into the file and then increase the file index by 1. And let's import JSON as well. Cool. The only thing we need to do is in settings, we have to include the pipeline. So to do that, we have to do Python pipelines, and then can set this to 1. So this is the order of we can have multiple pipelines. In this case we have only one, so we can just set it to 1. Just make sure this name matches our pipeline name. Yes, it does. So task scraping, correct. Pipelines, correct. And then task scraping pipeline. Okay, we should be good to go. One thing I forgot to add in tags.py was removing all the HTML tags if there is any from the text. So to do that, before actually yielding in tags.py, I can do page text equals remove tags and then page text. So this remove tags should be imported from import w3lit.html. Actually, let's do this from import remove tags. Okay, so now we're good to give it a go. Let's do scraping crawl tags, and we removed the output file parameter because now that's hard-coded inside the pipelines. Let's actually limit this to 1. Alright, this is going to take some time. But if we check the output files folder, now we can see that there are multiple files. And if you open any of them, you can see a single JSON element in them. So yeah, this is now done. We scraped about 36 pages. That should be good enough for our work to continue. And then we can just feed this into our chatbot. So let's continue. Just remember that the more context you provide, the more accurate your chatbot is going to be. Now that we have our files ready, let's create an index of all those files and feed it into our chatbot. Okay, so to do that, I'm going to create 2 new Python files. I'm going to call the first one create index, and the second one chatbot. Okay, let's start with create index. So as we mentioned before, we're going to rely on a Python library called llama-index for creating an index. Okay, let's go ahead and install that. So pip install llama-index. Okay, now it's installed. Let's go ahead and create the code. Okay, so I'm going to create a function named create and store index. Now I have to read all these files in the output files folder and then create an index. So to do that, I'm going to do reader equals, this is a good suggestion. So I'm going to use a simple directory reader. I just have to change the path. So instead of scraper, it should be tags scrapey and then output files. Okay, so we have to import this. So I'm going to do I'm gonna import this from llama-index. Okay, cool. So the next thing is docs. I'm gonna read the docs, and then I'm gonna create the context for this context is going to be fed into the chatbot. So service context from defaults. Okay, I need to import service context as well. And then I have to define my LLM. Okay, so in this case, we're going to use OpenAI. All right. And then model equals okay, you can use either GPT 3.5 or GPT 4. So let's go ahead with GPT 4. And then set the temperature. So temperature is basically a parameter for that measures the creativity of the chatbot. So the higher the number, the more creative it becomes and the more diverse the answers become, and the lower it is, the more deterministic. So we're setting this to a relatively low number because we want our chatbot to be as fact-based as possible. And then we have to feed a system prompt. Okay, so I have this text ready, and I'm gonna pass this on into the context. So we're basically saying you are an expert on Australian tax laws and your job is to answer questions related to tax. Assume all questions are related to tax return in Australia in July 24. Keep your answers technical and based on facts. Do not hallucinate features. Okay, this is good enough. But we can always come back and update this text. And now we have to create the index. Okay, so we're relying on vector store index. I'm going to import this. And then index. And then we're going to persist it into disk. Alright, that's all it is. So if name equals main, create a store index. Let's go ahead and run this. Okay, this is done, but we actually seen an error here. We've made a couple of mistakes here. The first mistake is this is not the correct OpenAI library we need. So I'm going to do OpenAI and then from llama-index import OpenAI. The other thing is we have to define our API key. So I'm going to copy paste my API key here. This is the one that we created as part of the first step. OpenAI API key equals key. Cool. Let's try again. Alright, this is now done. And then you can see an index folder being created here. And this contains our index files. Okay, that's really good. So now we're good to code our next file, which is the chatbot itself. And by the way, just before moving to the next file, we can also use the GPT 3.5 model here, which is free in case you don't want to pay for GPT-4. Alright, so for creating the chatbot, we're going to use the Streamlit library. Streamlit is a low-code Python library that can create simple UIs and can just speed up our development process. Alright, let's come here and then type in pip install Streamlit. Alright, let's give it a go. Import Streamlit as Streamlit. We're going to import OpenAI as well, and then set the API key. Alright, I'm going to import the vector index library as well. So we have to basically load the index that is stored on the hard disk into a vector store index. Okay, let's test this chatbot step by step. So first of all, I'm going to set the page config. This can include a bunch of information about the page, so like the page title, page icon, yeah, things like that. Okay, this is actually a good suggestion. So page title could be ask your tax questions. Page icon, layout, seems fine. Initial sidebar state, auto. Just gonna add menu items, none, to make it more simple. Okay, and then I'm gonna give the page some title, and then I'm gonna add my LinkedIn page to the top. Okay, so to run this, we can do Streamlit run chatbot.py. Yes, so this is a simple page that we just created. The title and the info. So now we have to add the chat dialog just below this. The first thing we're going to do is load the index. So I'm going to create a function called load data. Okay, I'm gonna add this. All right. So this is the text that's going to be displayed while the data is being loaded. This is where the index files are being read from. Okay, so let's stop this. And the first thing we're going to do is loading the index into a llama-index. So to do that, I'm going to create a new function called load data with state spinner. The first line seems fine. I'm gonna get rid of these. So storage context equals, this looks fine. I'm gonna import this. So this is the text that's going to be displayed while the index is being loaded. And then loaded index equals vector score index that load storage context. That is fine. And then we can return this. Cool. We can also cache this index. So results false. Okay. And now I'm going to load this index into a variable called index. All right. Okay, next step is initializing the chat engine. So I'm going to give it a name, chat engine. I'm just going to make sure that it's not created. And then if it's not, I'm going to create a new chat engine. As you can see, the chat mode is chosen as condensed question right here. So what does this mean? If you go to the llama-index documentation page, we have different modes for our chat engines. The one we're going to use now is condensed question. So what this means is, for each chat interaction, first generate a standalone question from conversation context and last message, then query the query engine with a condensed question for a response. So this is really good if you want to focus on the knowledge base or the context that we just scraped from the ATO website. There are also other chat modes that you can go ahead and try and see which one suits you best. Okay, let's go back to the code. I'm going to create a prompt for the user input. So if prompt Okay, so the next step is creating a prompt for the user input. So if prompt, let's spell this, if prompt and then your question. All right. Now I'm going to add a few lines for displaying the previous messages in the chat screen. So including the role and the content of the message. So role could be a user or the chatbot itself. And then finally, we're going to check if the last message is from the chatbot. And then we're going to check if the last message is from the chatbot, or as we call it, the assistant, then do nothing. Otherwise, create a response back. So to do that, we're going to do if session state assistant. Let's check the code. This looks fine. If it's not from the assistant, then we're gonna have a spinner and then create a response back with the role of assistant. This looks good. The only thing is we want to have a single prompt to begin with, so we don't want the chat dialog to be empty. So let's add that. So I'm going to do if messages not yes, this looks okay. Session. Yes, okay. So this is the first message that's going to be displayed to the user. Okay, so now we're good to go and start our chatbot. So I'm going to run this again. Okay, so the first message you see is that it's prompting that it's loading the ATO docs index. This is going to take a few minutes. This is essentially running the load data function that we just created here. So let's just wait for this. Alright, this is now done. So the first message we see here from the assistant is the one that we just typed in here. Okay. Now let's ask a very simple question to begin with. What is the average processing time for tax return in Australia? Alright, this is a good enough answer. And then if I say when is the tax return due, that is again a good enough answer. Okay, so as you can see, the answers could still be improved a lot. There are many ways to improve the answer, so we're going to discuss that right after this. Okay, so as you saw, creating a chatbot with a given context is actually really simple. There are a few things to improve. The first thing is providing the chatbot with even more information. So you can increase the depth parameter and give it more context so that it receives more accurate answers. There are a few other things that you can play with as well. For example, the temperature. You can also cleanse the documents before feeding them into the chatbot. Okay, you can try different models. We tried GPT-4. You can use the same library with different models such as Llama from Facebook. So there are a few things to play with and improve the accuracy of your chatbot. The next step is deploying the chatbot into the cloud and make it accessible to others. So this is something that we're going to cover in the next videos. Thanks for watching and leave comments if you have any questions.